My dear students, today I am going to discuss the NEET original question papers asked in the NEET examinations between the years 22-25 in topic wise, specifically under chemical bonding. Vetri welcomes you. So, the topic is chemical bonding and molecular structure. I have already given, this is the specific given in the NEET question paper. Unit is 3, chemical bonding and molecular structures. So, NEET original question papers between 22-25 I am going to discuss. So will be discussed by Dr.R.G. So let me go one by one. So before entering into that, in this particular chapter, what are the topics we have to study under this? Number 1, ionic or electrovalent bond. Ionic or electrovalent bond. So what is ionic or electrovalent bond? In this case, we have to discuss about the lattice energy, etc. Number 2, covalent bond. The second type, mutual sharing. Here various theory we have to study. Number 3, coordinate covalent bond or dative bond. And 4, metallic bond. And 5, hydrogen bond. So these are the subtopics we have to study well, then only we can able to answer the question asked in the NEET exam. The first question I am going to discuss, it is asked in NEET 22. Kindly follow. Choose the correct statement. Statement 1, diamond is sp3 hybridized and graphite is sp2 hybridized. Option 2, both diamond and graphite are used as tri-lubricants. Option 3, diamond and graphite have two-dimensional network. And 4, diamond is covalent and graphite is ionic. Diamond is covalent and graphite is ionic. So, please, students, I have red line under that is marked correct statement, because sometimes you will misunderstand incorrect. There may be confusion. So, among the 4 statements, which is correct, you have to identify. So, read once again all the 4. The most suitable answer is 1. Diamond is sp3 hybridized and graphite is sp2 hybridized. How? I will explain. Please follow. So this is the structure of graphite. Kindly follow. In the case of graphite, actually carbon electronic configuration is 2s2 2p2. This is the electronic configuration. So what will happen in this electronic configuration in terms of the orbital diagram? I can write like this. This is the ground state. In the case of carbon, this is the electronics, the state of ground state. What will happen in the case of excited state? So this becomes, kindly follow. So for the space is not sufficient, I am writing S above and below. So one of the s orbital jumps into the p orbital. Kindly follow now. So or we can write like this. Kindly follow. This is the way I can write. So 1, 1, 1, 1. So, okay. So kindly follow now. This is ground state. This is the excited state. So what is happening now? In the case of graphite, what is undergoing now? 1, 2, this is configuration we told 2s, 2p. This is 2s, this is 2p. So in the excited state, 1, 2s orbital and 2p orbital undergo hybridization to form 3 hybridized orbital. So this is the hybridization. We'll call it as sp2. sp2 hybridization. What about the third one? So now these orbital, 3 orbitals lie in a plane at 120 degree. What way? It will be like this. Kindly follow me. 120 degree. Like this. Or you can think of this way also. So this is a trigonal. The angle is 120. Kindly follow. Forming trigonal planar the structure. The remaining, that is 1, 2p is that orbital. It stands perpendicular to this plane. This is p orbital, stand perpendicular to this plane. So there is 1 electron here. So this is 1 electron, this is 1 electron, this is 1 electron. Please understand now. So this is without undergoes hybridization. So graphite is made up of layers. Please follow. This is the first layer. This is the second layer. This is the third layer. Understand now? So what will happen now? So when they are forming, just look here, this ring. Now I am showing you. Hexagonal. It is a hexagonal rings forming 3 sigma bonds with neighboring carbon atoms using sp2 hybridization. And the 4th electron remains without involving in hybridizations. So what will happen now? This electron is responsible for conductivity of graphite. So when compared to diamond, graphite is a good conductor because of this reason. Kindly follow. So the answer here, so graphite is sp2 hybridization. 1, 2p is that orbital is lying perpendicular to the trigonal plane. I hope clear. Now, coming for the diamond, it's also carbon, it's an allotropy. So, what is the this is the tetrahedron. Imagine, this is the tetrahedron. So, this is the carbon 4 sp3 orbital. sp3, 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 sp3. Kindly follow. As usual, you can write in the excited state, we have 2s and we have 2p. That is 3p. 2p, 3p orbitals, 1, 1, 1. So, 1s plus 3p undergoes 1 plus 3, 4 sp3 hybrid orbital. The shape is this. So what will happen now? So here each carbon is connected to another carbon tetrahedrally. So here all bonds are covalent. Please follow. So when compared to graphite, diamond is having higher melting point. Very, very important information. So graphite is sp2 hybridization, diamond is sp3 hybridization. So correct answer is 1. That is, diamond is sp3 hybridized and graphite is sp2 hybridized. I hope it is very clear. Now let me go for the second question. Here question is to match list 1 with list 2. This is the question asked in NEET 22 again under chemical bonding and molecular structure. Here left side they have given some hydrides, list 1. Right side they have given the nature, the compound nature. A, magnesium hydride, 1 electron precise. B, germanium hydride, 2 electron deficient. C, B2H6 boron, 3 electron rich. D, HF4 ionic. So what is the idea here? It is we have to match correctly. So they will give the option. See the option here? Option is, this is the option. Please follow. A1, the one option 1, A1A, B2, C4, D3. Second option 2A, 2, A2, B3, C4, D1. Third option A4, B1, C2, D3. Fourth option A3, B1, C2, D4. Simply by looking at this, you will be getting confusion. So don't worry about the answer side. You go for the corresponding list and put a line cross and write correctly and then compare with the answer. You will get the correct answer. So let me try now one by one. Kindly follow. The first one in the list hydride MgH2. So what is Mg? Metal with hydrogen. So it is metal involved mean it should be ionic. So it is ionic. So A should be 4. A should be 4. Option 1 is over. This is option 1. Kindly follow in the option 1. A equal to 4. Then come for germanium H4. Under germanium H4, you know germanium where it comes? Boron, that is the carbon, silicon, germanium. Carbon 2, germanium 3, carbon, silicon 3, germanium 4. It is 4s2, 4p2. This is the configuration of germanium, ground state. Or in terms of orbital diagram, S2, P2. Please follow ground state. In the excited state, what is happening? This one of the paired electron is the s orbital undergoing excited to going to the empty p orbitals. Now this 4s, 4p, they are in the same energy level. They undergo hybridization. What way? 1s plus 3p giving 4sp3 hybridization. Automatically, we can think of now automatically. So 4 bond it is formed. So germanium form 4 bond, covalent bond with 4 hydrogen. So automatically B you should be considered is electron precise. Why we are calling it as precise? What is meant by precise? Electron precise is a type of molecule or compound. Here, the total number of valence electrons is just enough to form normal covalent bond without requiring extra electron. I hope clear now. Let me repeat again. What is mean electron precise? Germanium H4 is electron precise. The reason is electron precise is a type of molecule or compound where the total number of valence electrons is just enough to form normal covalent bonds without requiring extra electron. So second part over. So B1. Kindly follow B1. Then third, boron B2H6. B2H6 nothing but it is the original of boron BH3, two molecules combined to form boron. So B2H6. It is unstable because the electronic configuration of boron actually, let me go now, the next page. So when you go for boron, 2s2, 2p1. So that means, so here 2s2, 2p1. So this is the ground state. In the excited state, what is happening now? This is getting excited. 1. See here? So automatically, this is forming 1s plus 2p, giving now 2, 3sp2 appreciation. Please follow. Now, what is happening now? It is electron deficient compound. Electron deficient compound requiring one pair of electron to form a central atom boron to form an octet. So that's why it's not stable. So two molecules, when they combine, automatically boron, you think of this, this is the structure of boron. Please follow. Now, automatically, now the boron is getting the sp3 hybridization. Kindly follow. This is the interesting information you must know. That means it is insufficient, deficient molecule. So you come over here. So we have already discussed A. So boron is electron deficient, C2. And lastly, the HF. The HF is nothing but the remaining is electron rich. So all are over now. This is ionic. This is electron precise. So everything is over. Kindly follow. Now you go for the answer and find out where it is. So there you should be A equal to 4, B. Now it should be 1, C it should be 2, and D it should be the correspondingly 3. So now we have to compare the answer now and you have to identify. The correct answer is, according to this, please follow, the 3 is the correct answer. A4, B1, C2, D3. I hope it is very clear. Let me go for the next question. This is also another interesting question asked in the NEET 22. Let me read now. Question number 3. Amongst the following molecules, Which one will have maximum lone pair electron repulsion? Actually, this question asked under valence shell electron pair repulsion theory. So we have to find out the number of lone pair present in each molecule. And from that question is, which one will have maximum number of lone pair? So we have to predict the bond hybridizations, and from that we have to find out the lone pair. So all the four we have to work out, then we have an idea. Kindly follow now. Here I have written number 1 SF4, number 2 XCF2, number 3 CLF3, and number 4 ILF5. Sulfur, it is nothing but 3S2 3P4, 3D0. 3 to 0. Suppose that is, in order to form sulfur tetrafluoride, actually the configuration is, I can write S2 P4. This is 2 electron, 1 electron. Kindly follow. So only here 2 electrons are not involved in bond formation. So what will happen now? D is empty. 5D empty. This is ground state. So what will happen now? During excited state, the one of the paired electron getting excited moving to the D. So I can now write sp3d. sp3d. That means 1s, 1s plus 3p plus 1d. So how can I write now? 1 plus 3 plus 1, 5. sp3d. This is the hybridization. So here, in this case, kindly follow, here P2 it is there. Only this is P4. So one of the p orbital paired electron is moving to the D. So in the s orbital, paired electron still there. So there is only one lone pair. Please let me repeat again. 3s2 3p4, s2 p4. So but here bond formation is 4 covalent bond it is formed. So 4 bond, 4 valent electron, unpaired electron required. So one of the p electron pair is getting excited moving to the D. So S P3D. 1S 3P 1D 5SP3. 1 plus 3 4 plus 1 5 SP3D. That means in the correspondingly 3S 3P 3D. So 3S2 lone pair is present. I hope clear? So in SF4, one lone pair is present. Now let me come for selenium difluoride. As usual, selenium comes under the helium, that is kindly follow helium first group, neon, argon, krypton, xenon, 5. It is 5s2 pi p6. 5s2 5p6. 1, 2, 3, 4, 5, 6. And D empty. D empty. Kindly follow. So what will happen now? How many bond it is forming? Only 2 bond it is forming. But this is completely, this is 5s paired, 5p completely paired, 5d empty, ground state. Actually, it has to form 2 bonds. So what will happen now? One of the p orbital in the outermost getting excited moving to the d orbital. So now I can write now, what is the orbital hybridization? 1s plus 3p, kindly follow, 3p plus 1d. 1d. So what will happen now? 1 plus 3, 4 plus 1, 5. 5 sp3 d hybridization. The interesting information here, 5s, one lone pair. In 5p, there is here one lone pair, here one lone pair. So there are 3 lone pair in this selenium. Because it's only forming 2 bond. One formation to 1 p orbital, unpaired electron, another unpaired electron present in the d orbital. Okay? The same way, so in the case of sulfur, we observed 1 lone pair, selenium 3 lone pair. Now we go for chlorine and iodine, it is almost identical in nature. Only thing is the period varies. So let me take chlorine. Fluorine 2 and chlorine 3. So 3s2, 3p5. So 3s2, 3p5. 1, 2, and 3d. Kindly follow 3d. 3s, 3p, 3d. So what will happen now? How many bond it is forming? ClF3. F3 means only 3 bond is forming. But how many unpaired electrons? 3s2, 3p5. So we need 3 unpaired electrons. So one of the p, kindly follow, paired electron is getting excited and moving to the d orbital. Moving to the here, moving. So what will happen now? Automatically hybridization is as usual sp3d. sp3d, but lone pair now in 3s one lone pair, in 3p one lone pair, there are 2 lone pair present in the chlorine, ClF3. Now fourth, you go for IF5, iodine pentafluoride. It is, I means 5, so 5s, the configuration same, 5s2, 5p5, I can write 5s2, 5, 5, and the remaining is 3d, 5d. Kindly follow 5s, 5p, 5d. The idea here it is, how many bond it forms? 5 bond it is forming, covalent. So but here only one valence electron is there. So as per the rule, one of the paired electron from the p orbital going to the next d orbital. The same way another paired p orbital going to the next d orbital. So I can now write the configuration, excited state. I can write like this. S2, that is 5s2, then 5p3, and 5d2. 1, 2, 3, 4, 5. D2. That means yes, P3, D2. That is actually hybridization is sp3d2, but lone pair is present only in 5, so only one lone pair. So our question is, which one among the following will have higher lone pair? The answer should be, this is the case. So we'll go for the number answer. So among us the following, which one will have the maximum lone pair repulsion is 2 is the correct answer. Okay, next question. 4. This is simple statement, but anyhow, you should be careful. Which among us the following is incorrect? Please follow. The previous one correct. Here incorrect statement. NEET 22 it was asked. Number 1, H2 H2 plus ion has one electron. 2. O2 plus ion, that is O2 plus ion. O2 plus ion is diamagnetic. 3. The bond orders of O2 plus, O2, O2 minus and O2 minus are 3, 2, 2.5 and 1 respectively. And 4. C2 molecule has 4 electrons in its 2 degenerate pi molecular orbitals. So these are the statements given. They have asked which is incorrect. The question itself, it is very, very easy. The first one is incorrect because in the hydrogen, automatically we have only one electron present in hydrogen atom. So that when you say 2 plus means there is has one electron. So H2 plus ion will not have one electron. This is incorrect. This is incorrect. Whereas O2 plus, O2 plus, O2 2 plus, O2, O2 2 minus and O2 2 minus are 3, 2, 2.5 and 1 bond order respectively. C2 molecule has 4 electrons in it to generate. So these statements are correct one. So if you want to explain this, even though it is, so we have easily identified H2 plus ion is as 1 electron is incorrect. We have identified easily. But you must know also the explanation for the other. Let me go for the worksheet. Kindly follow. You, in this case, you understand this one. That is, kindly follow. This is the oxygen molecular orbital theory. According to molecular orbital, so we can write 1s, 1s. So let me give an idea. What is molecular orbitals? Atomic orbitals undergoes hybridization, undergoes molecular combination to produce molecular orbitals. Total number of molecular orbital formed is equal to total number of atomic orbital involved. There are 2 types of molecular orbital. One is bonding, another is antibonding. Bonding, low energy, antibonding, high energy. Electron present in the bonding will favor bond formation. Electron present in antibonding will unfavor bond formation. Here the point is bond order equal to total number of electron present in bonding molecular orbital. Total bonding electrons in bonding molecular orbital divided by total electrons present in the antibonding molecular orbital. Antibonding molecular orbital, that is multiplied by, or that is half into, kindly follow, half into total number of molecular orbital present in bonding divided by antibonding, then 2. Kindly follow. So in this case, even though it is shown here, 1s, automatically we know the oxygen atom is, in the case of OS, oxygen atom combined to form O2 molecule. Please follow. So in the case of here, automatically 1s2 actually completely filled. This is also 1s2 completely filled. So automatically 4. So one is bonding, this is antibonding. So it is both balanced. And so for same 2s, 2 electron, 2 electron. So bonding, this is antibonding, balanced. So actually to give answer, better we will discuss about we will take care of only the, kindly follow, p orbital. Kindly follow. Only p orbital we should concentrate. So in the case of, what is the p orbital? 2p Kindly follow. In the case of T, two P 2s2 2p4. So 2p4 in one oxygen atom, another oxygen atom 2p. So 4 electron there. See here, 4 electron in each oxygen atoms. So automatically px, py and pz. And here automatically the one will be the px and py will be the pi molecular equal orbitals, pi molecular will giving pi bond, and sigma the z will be the correspondingly we will think of the molecular axis forming sigma bond. So totally 4 plus 4 in the case of O2 molecule, please follow, 4 plus 4 8. So lowermost it is given 2, then again so 4 plus 4 3 plus 3 6, lower 3 higher 3, bonding 3 antibonding 3, totally 8 electrons. So 8 electron lower 6 I filled and higher in the one unpaired electron, another unpaired electron. So according to the bond order, 6 minus 2 by 2. So 4 by 2, it is the bond order is 2. That's why oxygen is double bond. Please follow. So 2 unpaired electron is present in O2. Suppose O2 plus means one side 1 electron less. 1 electron less means 4 plus 3, 7. So 6, the top one 1. So 6 minus 1 by 2, it is 5 by 2, 2.5. O2 plus 2.5. So suppose O2 minus, if you say, one side 5, another side 4, one electron extra. So 5 plus 4, 9. So below 6, above 3, again one unpaired electron. So 6 minus 3, 3 by 2, 1.5. So this is the way we have to calculate the bond order. Kindly follow. So in this case, this is the correct answer. O2 plus ion is diamagnetics. What if they paramagnetic and diamagnetic? If there is no unpaired electron, diamagnetic. If there is any unpaired electron, paramagnetic. And bond order also I have shown you how to calculate it. So C2 molecule actually, the two sides, it is forming only 2 pi bond. That is bond is 1 sigma and 1 pi. It is forming 2 degenerate pi molecular orbital. It is forming carbon C2. It is forming. Because what is carbon electronic configuration? 2s2, 2p2. 2s2, 2p2. So, this is the way we have to follow. Next question. The number of sigma bonds, sigma and pi bonds and lone pair of electrons in pyridine respectively are, this question was asked in NEET 23. NEET 23. Kindly follow. In NEET 23 it is asked. Number 1, 6, 3, 0. 2, 11, 3, 1. 3, 6, 2, 1. And 4, 11, 2, 0. So the only problem here is, my dear students, you must know the structure of pyridine. Without knowing the structure of pyridine, we cannot identify the configuration. So, this is the pyridine. Kindly follow. This is the pyridine molecule. So, there is lone pair electron, it is there. Nitrogen is 2s2, 2p3, 3 bonded, and one lone pair. This is the structure. Now you count now what they are asking. Sigma bond. So let me now, this is 1 sigma. Here out of 1 pi, 1 sigma. Here only 1 sigma. Here 1 sigma, 1 pi. Here 1 sigma. Here 1 sigma. So totally 6 sigma. So only probability either 1 and 3. Either 1 or 2. 3 will be correct. Now let me go for pi bond. See here 3 pi bonds are there. So automatically you will think of 6, 3 is the pi bonds. 3 pi bonds are there. And coming for the lone pair, here it is 1 lone pair it is present. 1 lone pair it is present. Actually, this is the 3. It should be 3. So, 6, 3, 1 should be the correct answer. Kindly follow. So, the number of sigma bonds 6, pi bonds and lone pair of electron pyridine are. So, it should be 6, 3, 1 will be the correct answer. So, it is the typed the wrongly 6 to 1. It should be 6, 3, 1. So, let me go for the structure. See, this is the structure. So, automatically lone pair here, it should be shown outside because pyridine is it's aromatic. It is hetero-aromatic compound. Aromatic compound. Hetero-aromatic compound. What is homo? Hetero. Homo means all the atom in the cycle will be same. Benzene, homocyclic. The pyridine, heterocyclic. So, correct answer is, you kindly follow here, 6, 3, 1 is the correct answer. Kindly follow. I told you already, 6, 3, 1. It is the correct answer. 6 sigma bond, 3 pi bond, 1 the correspondingly lone pair. The next question, amongst the following, the total number of species not having 8 electrons around central atom in its outermost shell is 1 ammonia, 2 aluminum chloride, 3 beryllium chloride, 4 carbon tetrachloride and phosphorus pentachloride. Question was asked in the year NEET 23. So, what is meant by 8 electrons? Normally, this is called octet theory. So, during the formation of any molecule, the central atom should have 8 electrons. None will be, it will be stable. If 8 electron is not present, it is deficient. Example, boron, we have discussed BH3, electron deficient compound. Some cases, phosphorus pentachloride, electron excess, PCl5. It will be, outer will be 10 electron in the outermost. So, they will not obey the octet theory. So, normally molecules obeying octet theory will be more stable. Here question is, among the following, the total number of species not having 8 electrons. Since the structure is given, we will write the structure and identify which is having 8 electron, which is not having 8 electron. Please follow me. So this is the 4. Kindly follow. Number 1, ammonia, aluminum chloride, beryllium chloride, carbon tetrachloride, PCl5. So, coming for nitrogen atom, electronic configuration 2s2 2p3. 2s2 2p3 means, kindly follow, here automatically the 2p3 unpaired electrons are involved, so 3 bonds are formed, so 1 lone pair it is present. Coming for here, 3s2 3p1. So 3 bond, aluminum having the 3 bond, Cl, Cl, Cl. So S2, one of the S2 is getting and going to the P2. So sp2 is forming. So automatically this is having the interesting information here. It is kindly follow the sector 2. This is aluminum chloride 3s2 3p1. Then kindly follow here, this is electron deficient. Here ammonia, there is lone pair here. In aluminum chloride, electron deficient. So here 8 electron is present. Here not 8 electrons. So not present. This is not present, 8 electrons. Beryllium only 2. Kindly follow 2s2 means only 2 bond. Beryllium dichloride. So only 4 electron will be in between. So this is also coming under this one, not obeying octet theory. Carbon tetrachloride, again carbon S2P2 4. So it is the sp3 hybridization. So it is obeying 8 electron. And PCl5, as I already informed you, this is not obeying octet theory. So answer will be 2, 3, 5 will be the correct answer. 2, 3 and 5 will be the correct answer. So the answer is 4, 2, 3 and 5 will be the correct answer. I hope, my dear students, I will stop with this as a part 1. I will continue the remaining questions in the next class. See you. Bye-bye. Dr. Gunasekaran. Thank you.